All right, so where are we at? What section? 12.6.1. 12.6. A, in the following figure, identify three pairs of lines that appear to be parallel. Yeah. So, let me ask you this. Do BC and GF, do they appear to be parallel? Let me ask it a different way. Do BC and GF have the same slope?
No.
Okay, so they're not parallel, right? You guys see that?
Yeah.
Does the distance between BG and CF stay the same? The distance between BG and CF, does it stay the same?
Nope.
Nope. Okay. So are there any that look like they're parallel?
Any lines on it?
Yep, any lines that look like they're parallel to each other.
No.
Yeah, for me, I would say maybe A, B, and EF. Maybe. Maybe A, B, and EF. But even they don't look like they have the same slope, yeah? But are any skew? Are BC and AD, do you think that they're skewed? What does it take to be skewed? Yeah, to be skewed, they can't be parallel, but they have to not intersect. And you can only do that if you're in 3 dimensions, yes? You guys see what I'm saying? So, AD and BC look like they might be skewed. Yeah. Now I will say, the picture is not the best. What about DE and BG? Let's miss those. Those are tiny little things, it's easy to miss. What about DE and BG? What do those look like they might be candidate for?
Parallel lines?
Yeah, they look like they're parallel. Okay, so you could be apart in 3 dimensions and be parallel as long as you maintain the same distance from each other, correct?
Yes.
We've expanded the definition of parallel because once you're out of 2D, saying that they don't, saying that they don't intersect is not good enough. Because these lines don't intersect, but they're not parallel, correct? So a better definition is the distance between the two stays the same and is more than 0. Yes? So do you guys see how BG and DE could be parallel? What about CF and BG and DE?
Yeah.
Those look like they're probably parallel, yes? Okay. And then skew just means they're not parallel, but they don't intersect. Right? Not parallel, but they don't intersect. And that's why you need a 3rd dimension. Does that make sense? If I'm in 2 dimensions, is it enough to say to be parallel lines you have to not intersect? If I'm in 2 dimensions. Yes. Because if they don't intersect in 2 dimensions, I can't do anything but be parallel. But the minute I allow a 3rd dimension, see this is 2D, yes? My arms line a plane. The minute I allow a 3rd dimension, then I introduce the possibility they're skewed. So what's the difference between skew lines and parallel lines? Skew lines don't intersect, but the distance between the two doesn't stay the same, yes? So right here is the closest it comes, but then here, that's much different distance than anything else. It doesn't stay the same distance. Okay, I like it. It's really trippy. Yes?
By 4 pairs, that means like 4 different. So like
3 pairs of lines that appear to be parallel. Yeah. BG and DE, DE and CF, CF and BG. Yeah.
And then what's dihedral?
Oh yeah, what's dihedral? Does anyone remember dihedral? It sounds like either a marine biology term. The dolphin has a dihedral fin. No? Is it just me? Anybody remember what dihedral?
Dies too.
Sure, yes. So two planes come together and they make an angle. Yes?
Oh, and it would be it.
So if I take, here. You guys all brought your kits today, yeah? If I take two planes come together, the angle they make is the dihedral angle. Yes? No? Is that like a 90-degree angle they make? The two planes? Yes? So there you go. You understand dihedral. So when I kind of tilt it, is that less than 90-degree angle they make? Yes. You guys kind of with me?
It's just less than 90 degrees.
Say again?
It's just less than 90 degrees.
No. Dihedral angle is the angle that two planes make with each other. So it could be anything. That would be greater than 90.
It's an acute dihedral.
Yes,
It's not
acute.
less than-
Acute little dihedral angle. Yes. Say again.
So for that, we would say.
The question is a bit misleading, I think. It says describe an acute dihedral angle. So for example, the angle between this top plane and this side plane. If I kept it going, you can kind of see it's going to be an acute angle between, or even the bottom plane and the top plane, if they actually came together, they would make an acute angle. The top plane and the bottom plane looks like it makes an acute angle. Yes?
So you just would say DAE.
But I think the question sounds more like they want you to define it. They didn't say
So write
Find.
an explanation.
yes.
Okay.
Okay. I like it. Okay. How many of you guys have gotten into 12.6 homework yet? A few of you. Okay. You desperately need to get in there. So the way this class works the best is if we discuss something, you try to get a little bit of it going, see if you have any questions, come back the next time at the beginning of class, leave room for questions, yes? If you don't have time to do the homework, just kind of scan through, see if anything doesn't even sound like what the shit does that mean? Then ask that question, that's fine. So I haven't done this yet, but what is this asking for? Little tears, okay. It was then asking for tears, but I will give you little tears. Okay. Anything else from homework stuff? 2, 4, 6, 8, 10, 12. Lucky number 13. Hey! Nobody on this side. This side something has happened. I don't know what's happened to these guys. Maybe I'll have a lot of emails when I get back. Okay. Alright guys, so if there's no more questions from 12.6 homework, I want to let you work on something. I went and I didn't really steal it because I had to ask for it, but I got the remaining kits. So if you didn't get a kit, you can have one of these. They're signed out to me, so I'm going to keep extra special attention of you if you take one of these too. Oh man, I'm destroying the bag. Poor little guy. There. So everybody got a kit. Everybody bring their kit.
Are we going to use that in high school compass?
You specifically.
I got it.
You got it, but you didn't bring it. Oh, that's great. At least you're here. That's good. Yeah.
Are we going to need that thing, the compass and stuff?
Not yet. That's coming up later. Yeah.
I didn't know.
Oh, I got some extra.
Oh,
So this will be part of what I can do is slowly try to get the bags up to where they need to be. All right. So I've got a little worksheet. Oh, good. And I want to give it out, and then I want to explain how to do a few of these. I'm gonna have you guys work in groups, and what I want you to do, I'm gonna try to put the people that don't, if you don't have a kit, raise your hand again. Like right now, with you. So, okay, thank you. I'll make sure to not put you guys in the same group, that would suck. So what I want you to do is, not every problem in here requires the use of your kit. In fact, none of them do, to be really honest, but I'm gonna make you use your kit on a few of these. So let me give these out, put you guys in groups, and then we'll talk about how to do some of these. Wow, you got like a big old thing, I like it. No. 14. Alright, let me see. We'll do the tried old tradition of counting off, because alright guys, how you doing, neighbor? Being like a rocket. Oh, I see, that's way cold. Okay. Sean, yeah. You wish you was good. So let me see, has anybody got any shapes they put together they want to showcase?
Wait,
Oh, what you got?
this is the best one.
Ooh,
It's almost
coming up here.
She's almost done.
Alright, she's almost done. The last little snap.
Wait, don't look at me. I'm just on.
Everybody stare at me. We got a really cool shape about to happen over here. Oh, come on up, yep.
Hooray.
Alright, yeah. Okay, and do you know what that is?
I have to look at my paper.
You're good, you're good.
It's 20-sided, guys.
Yes, so you're ready for,
It is a
alright,
But yeah.
alright, it's been saved, maybe. That's not gonna be easy. So, cool, thank you. How are we doing there, Avery? I'm very excited to hear. I love it. Okay.
It's a hotel, it's fine, there's supposed to be a door.
Do you guys want to stand up or you want me to show it?
Well, this isn't complete, so.
No, this is perfect.
It's fine, think about creative.
I wonder if it was
creative.
It's
It's nice more.
I think it's
Are you gonna show it off a little?
I would show it.
Okay.
Come on.
Careful, don't, okay. You have a name for your creation? So guys, there's a piece of architecture here. Would you say what's like a hotel?
It's like a hotel with a door.
Kick ass. And the thing on top spins around? Yes, and there's lights that come out. I love it. I'm sorry, I'm hyping up your hotel.
Okay.
Thank you. When you come down to the last few pieces, the other pieces don't want to stay. We're so determined, I love it. Alright guys,
I'm gonna get it.
it's coming, there's one more coming. While you're doing that, oh shoot, please don't, hurt yourself. Let's look at a few of these problems. So which one of these is, oh shit, which one of these is not a polyhedron? Yeah, why?
Because it's has a curved,
Yeah, so, guys, real quick, guys. Most important aspect about a polygon is, what would you say? For a polygon. Oh shit. So polyhedrons are constructed, their faces are polygons. And what's it take to be a polygon? Line segments. Good, that's one of the most important things. So a simple closed curve made of line segments. Yes? Okay, cool. So obviously 5 can't be a polyhedron because one of its sides, in fact, yeah, all of its sides are curved. Yes? And of course, same thing on the next few. Which one of these? Is there an issue with that? Do you guys remember the name of that if I did it on every vertex here? You guys remember what I would call that? It's called a truncated cube. If I did that to every single vertex. So this is not a fully truncated cube, but it's still a polyhedron, yes? What's the only one of these not a polyhedron? Yeah, the mailbox, no good. Same reason. It's not constructed with polygons. Now, everybody hopefully put together some of the more simple shapes here. What was this identified as?
Square base pyramid.
Yeah, good. So when you put it together, you get this guy, and it's a square-based pyramid. What about this guy? Which picture did this become? Yes, so it became this guy. And the way to remember how to name that, a prism is fundamentally a repeated shape. So one place where me and this book disagree is a cylinder to me, mathematically, is a prism. It's a repeated shape. This book specifically, for whatever reason, says a prism must have a polygonal base. Yes, you guys got it with me? So therefore, I wouldn't call a cylinder a prism, but it does call this a prism. It's a repeated triangle. And a triangle is a polygon. So this would be a triangular prism. Crazy. What have you put this together?
I did it.
Say again. This guy. Now, the word for this out of, well, let's come back to it. So this is definitely this. The little star next to it. What does this become here? Say again, sorry.
Triangular base pyramid.
Yeah, tetrahedron, triangular base pyramid. So that would be down here. And of course, this is definitely going to become. This is one I don't think everybody could put together, maybe, but I don't know if you guys managed to put this together. But this becomes a hexagonal prism, yes. So therefore, what's this one got to be? The word for this one. Cuboid. Okay. It's not quite a cube because one side is, several faces are rectangular, but it's kind of like a stretched cube. Okay. And then over here, first one's pretty straightforward, yes, because it's the same thing on the front page, so you can't go wrong with that. Cube. This one, I think nobody really had too much trouble with this. And the great thing, if you think about it, what's one of the hardest things to get from a picture? If I just gave you this picture, isn't it really difficult for a young student, and sometimes us, to tell how many total faces it has? Whereas if you have these pieces, the students are putting together, they can actually count the faces as they put them together, yes? And of course, how do I identify the name of a polyhedron? According to the polygons that go into its faces, yes? Okay. So this one, actually I name it by the sides, but the number of faces it has. So how many faces does this have? 8, so it's an octahedron. And of course, when you put that together, you should have gotten, bam! This one gave some of us some trouble. I don't blame you. It's very trippy when you try to kind of see how to kind of put that together from the picture. When you wrap that sucker up, how many faces would this have?
20.
Yes. So who remembers, I think, so I just heard, oh, is that the one? Yeah. So this makes a whatchamacallit?
2075. Or
That's right.
icosahedron.
Icosahedron, and then that would be 20-sided. Oh my gosh, they have. I guess it's this guy, yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11. Yeah, yeah.
The only one with triangles with more than 5 sides.
Exactly. And then of course this guy is from same one from the front page. Tetrahedron. And then this one I don't think many people had enough parts to put together, but dodeca means 12. And there are 1, 2, 3, 4, 5, 6. So no. And the only image that's left to pick from is this. Okay, I like it. Not too bad. How you guys feeling? So you could very easily see I could give you problems like this on a quiz or a test or something. And then the last page, this is that weird, very mathematical relationship between these elements of a polyhedron. And again, this is a perfect example of, from an image, it's really not easy to tell, especially this one for some reason. This is a horrible representation of this. But it's got 1, 2, 3, 4, 5 faces, yes? That's a terrible picture. I don't know what happened to it. How many vertices? 1, 2, 3, 4, 5 vertices. How many edges? Yeah, 1, 2, 3, 4, 5, 6, 7, 8. And then F plus V minus E is 2. That's exactly what it's supposed to be. So we talked a little bit about that relationship last week. It's just a neat thing that happens, right? Just a neat little observation to make. So how'd you guys do on number 14? Anybody got that? How many faces? 8 faces. How many vertices? 12. And how many edges? 18. So 8 plus 12 minus 18 is 2 again. And this one, what would you guys call this one?
Octagonal prism.
Dude! Octagonal prism. Because it's an octagon that's been repeated. Kick ass. How many faces does this little dude have? 10?
10.
How many vertices?
16.
16. How many edges?
24.
24. 10 plus 16 minus 24 is 2. Okay. So, can you imagine, before you even talk about polyhedron, in fact, this is basically what happened here. When I talked about the kits and you guys took them out and you were putting stuff together, even before I said anything, you constructed some of the shapes you constructed today. Yes, some of you guys definitely did. Could you imagine a student doing that? And then you say, look what you discovered. You discovered this. This is what that is. Because of how many sides does it have? How many shapes do you go into putting it? Do you guys see what I'm saying? So it's less of a definitional thing. It's more of a discovery thing. And then you come in after the fact and go, oh, look what you made. You made something with this many sides. Right? Okay. I like it. Maybe. Okay. Sweet. Alright, so a little bit of lecture today about, we're going to get into chapter 13. Incredibly enough. So go ahead and, I think everybody's back to your places. Okay, I like it. Oh, what's it? Oh yeah, good. What are you? Tell me what's on your mind. So, let me ask you this. Guys, how many systems of measurement for length are there on the face of the earth at this moment that we know of? How far apart would you say 2 towns are? What measurement would you use? Miles. Oh, did you get it? Okay, real quick.
It's
football.
It's a
Anybody in here, this looks roughly like, well, now I don't want to show off my cultural ignorance. Kind of reminds me of a dreidel.
That's what I just said.
Oh, is that what you said? Okay, sorry. Didn't need to take away. The Felicity came over that, looks like a dreidel. If you don't know what a dreidel is, it's like a Jewish thing they made out of clay, and they put stuff, symbols on the sides, and they kind of twirl it. Okay, I like it. That's really cool, look at that. Oh, yeah, I'm sorry. It's I love it. It's polygonal football. Now, what, we use miles, feet, so forth here, yes? You guys all with me? Okay. There's a bit of an urban legend that sort of ties to truth. The thing we call a foot, what's not true about it is, it's not the size of King Henry's foot. But it is true that King Henry did establish what a foot should be. It's actually the distance from, a yard was the distance from his nose to his outstretched thumb. Yes? That's what they call a yard, and 1/3 of that was a foot. Are you guys kind of with me? And what I always say, so, you guys know the metric system? Anything about the metric system? Yes, good. So in our system, we have miles. In the metric system, they have kilometers. If you've ever driven, I think it's the 15. I can't remember how far you have to go up, but there's one sign I've seen that talks about the next town is so many miles, but it also lists kilometers. That's like one sign I've seen in the States. And by the way, I went to Canada on a road trip a while back. And when I came back across the border, it was such a shock to see the first speed limit sign. When I saw it, I was like, whoa, that's so slow, because I was thinking kilometers, right? So, how many countries on the face of the earth currently do not use the metric system? Just us. Yes. That's great. There was something that happened with the Mars Climate Observer. I've already talked about this before. Alright. I'll wait for things to happen with everything. So, there were 2 different groups working on this Mars Climate Observer. Yes? When they were communicating about trajectories and so forth, one group was using metric and the other group was using not metric. So what happened was, it was not supposed to go into the atmosphere of Mars, because it wasn't designed, it was supposed to kind of orbit Mars. But since they didn't record the measurements correctly, it actually ended up going into the atmosphere, burning up, and that was like some billions of dollars, so. Kind of bad, yes? So, it always surprised me, that's a true story. And it's so surprising that science always uses metric, because then every scientist around the world knows what each other was talking about. You guys are all with me. The physics department here always gets upset if we ever do stuff in feet, in inches, and I'm like, well, we have to, we live in America, we want to. So, let me ask you this. Do you guys know what time is based on for us? Like, you know the units. 60 seconds is a minute, 60 minutes, blah, 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 blah. You guys, is everybody with me on this? This is so true. Okay. How do I know how long a second is? Have you guys ever heard of an atomic clock? Have you guys ever heard the phrase atomic clock? No. Okay. I'm not going to suddenly start teaching you physics or chemistry, but I am going to talk a little bit about it. If I measure the time it takes for a cesium atom to go to an excited state and come back down, I could use so many of them. Off the top of my head, I can't remember how many, but it's millions of them. And then I can say that many makes 1 second. So when we say atomic clock, that's kind of like the standard we measure against. So you can actually go online, search atomic clock, and you can see the official time according to the atomic clock. In fact, back in the day, there used to be an app where you could set your computer's clock according to the standard atomic clock. Are you guys all with me? Are you guys, so. Has a student had a reason by the time they entered kindergarten, first grade, so forth, to worry about how to measure things? What's the most important measurements to students in that situation?
Their height.
Sure, okay, so their parents could have made a big deal about their height. And they could even be doing the thing where you mark it against the wall and so forth, yes? We moved a lot when I was a little kid, so we didn't have that experience of having a wall with it. Does anybody have that experience where you live in the same house and you have the wall? No? You have?
Yeah.
So you have a wall somewhere that's got your heights?
Mhm.
That's cool. See, then I'll come back when I'm like 80 and then start to go down again. Oh, shit, okay. So, when you're trying to teach students, little ones, the first experience with units of measurement, they don't have something in their own life necessarily to draw on. Now, they are curious about stuff like, how many toys do we have? Yes? They don't have a clue about money. They don't necessarily understand temperature, because they don't have to. They get, somebody else watches out if they need a jacket or not. They don't care too much about money, they don't care, okay. So when you're first starting to work with little people about measurements, which you very often want to do, and this is something I wouldn't necessarily would do with any of you guys, but you could have somebody pick a person and then measure a line along the floor with that person. So maybe you have Sarah, and you say, Sarah, coming up, and she lays down, and you lay down, and you say, that's 3.5 Sarahs. Do you guys kind of see what I'm saying? You guys kind of see what I'm saying? Then it becomes sort of a game for a little while. Okay, how do you measure how long this is? Somebody else have an idea. Well, how about eraser? Okay, how many erasers long is this? So that gets the idea. What idea does that give them? If I want to see how long something is, I could either use so many Sarahs or so many erasers or so many paper clips or whatever. What idea is that establishing? Does anyone see what idea that's establishing?
Like units of measurement?
Sure, but standard units.
Yeah.
So you can imagine a time on the face of the earth. In fact, it's still going on. Does everybody agree with the units we use to measure things?
No.
Obviously not. We're the one standout, holdout, yes? Why is it important? Obviously, it's important that we all measure things to a certain standard. Do you guys agree with that? Because otherwise, what could happen? You could have your Mars climate observer burn up in the atmosphere of Mars, yes? Not the best thing in the world. Big old waste of money. I like it. Okay, so time has a natural unit of measurement. You don't necessarily want to talk to your students about measuring how long something is in the excited state for a seizing matter. That's maybe a little beyond. What do we use, of course, in the States to measure how far apart two things are? What's the most basic unit?
Inches.
Inches. So, when I'm trying to measure something, the real idea of using Sarahs or erasers or whatever is you want to use the same shape, the same thing. You want to use something that's congruent to a certain standard, yes? So why would somebody else measuring something with their eraser not be good? If I have several people, everybody measuring something with their erasers.
Because their erasers might not be the same.
Exactly. Somebody could have just bought a new eraser and somebody else is using the eraser they had at the beginning of the semester, so it's like a little nubbin. Yes? Okay. So what's really cool and what's really nifty is there is a standard for a kilogram. Let me see, I wrote it down somewhere because it's really interesting. I think it's 90%. Let me see if I have it here. There is a standard kilogram that they have in, here we go. All right. In the UK, I believe, they have the standard prototype kilogram. And it's something composed of, it's 39 millimeters tall as a cylinder that's made up of 90% plutonium and 10% iridium. So it's a cylinder made up of this stuff, and it's 39 millimeters tall and it's 39 millimeters in diameter. So it's the same distance this as it is there. And it's just sitting there. Sort of like the atomic clock. I can always compare my clock to the atomic clock and make sure that my clock is good. I can compare what I think is a kilogram to the actual standard prototype to see if mine is good. You guys good? Sort of like in a classroom, you could have everybody measure the same exact image with their own erasers and see all the different answers people get. And they will naturally see there's an issue that needs to be taken care of. So you guys see that? So then you could agree that maybe Jesse's eraser is the standard. And then if you want to measure something, you have to use Jesse's eraser so everybody knows what you're talking about, yes? Okay, I like it, I like it. And of course it would have to be Jesse's eraser on that day at that time, because it's changing over time. Okay. Well, has anybody ever heard of fathoms? Anybody ever heard of fathoms? So many fathoms, very often you hear it nautically. So many fathoms beneath the sea.
Yeah.
Okay, does that sound at all familiar? So you've heard of it?
All the leagues on.
Leagues is something else.
Oh.
Yes. But I'm with you. 20,000 leagues under the sea, that's a different thing. So fathoms, you've heard of this. A fathom is actually 6 feet. Just in case you've ever heard of fathoms. Has anyone ever heard of? Do you guys know in the UK and in Ireland and so forth, they still, and in fact, I think it's, I can't remember right off the top of my head where we still use this, but you measured weight in stone. So very often you hear somebody say, "Oh, they're 7 stone." So literally, historically, you would measure how heavy an oxen was by basing it on stones. How many stones does this oxen weigh? Now, automatically, what's the issue? Same thing with the erasers, correct? So eventually, they still use stone. You will still hear somebody talk about the weight of something in stone. But what did they have to do in order for this to still make sense? They had to standardize it, yes? So in general, any measurement you want to try to use, in order for it to make wider sense, it has to be standardized. So stone is 14 pounds. Roughly. Do any of you guys cook? Do you guys cook at all? Does anyone have like recipes from your grandma or something? Anybody? Or from your mother? Yes? Did they ever write a dash of salt, a pinch of this? In fact, that's some of the best recipes, because each time you make it, it's a little bit different, which is great. Right? I love to cook. I love to bake. It's yummy. It's awesome. So, when I say a dash of salt, does that mean the same thing to everybody? No. Why is it not really that big of a concern?
Just for taste.
Yeah, it's just for taste. So, I mean, if you want yours a little less, your dash could be smaller. You have variety amongst, oh yeah, I love, my grandma loves this, but when you make it, it's different because your dash is like huge and it's way too salty, whatever. You guys kind of. So something like a recipe colloquially doesn't have to have like a standardized unit when you're talking about those things, yes. In baking though, you do have to be a little more precise with some of your ingredients. If you've ever baked before, you know this. I remember the first time I tried to make pumpkin bread, it came out like pate. It came out all jiggly, and I was like, well, that's not good. So I was off in my measurements. Okay. The inch. Has anybody ever heard of a barley corn? Yes? So barley corn is like an acorn. It's like a little nut, little seed. And if you put 3 barley corns along in the length, that would make an inch. So an inch used to be the length of 3 barley corns. So it's really art. The evolution of units that we've used by itself is a really interesting deep dive study. I'm not going to get that deep into it, but I do want to give you a few little insights into where some of these things came from. So this would be 3 barley corns long. Oops. So I already talked about the yard. What about an acre? You guys have definitely heard of acres, yes? Unfortunately, in California, the main way you hear about acres is how many acres are on fire somewhere, yes? An acre was originally the amount of land that an oxen could plow before they need a rest. Which is a very strange way to measure anything. So obviously we had to standardize that at some point. In fact, the word acre comes from Old English for plowed field. I'm pretty sure you guys might maybe heard of furlongs. Anybody ever heard of a furlong? Has anyone ever heard of a furlong? No? That's okay. It's 660 feet. Okay. Just in case this comes up. So throughout history, there's been a lot of different attempts to standardize units, and sometimes the original way the unit was used was not very standardized. If somebody has barley corns that are a little different, then their inch is going to be different. Somebody lays them out differently, their inch is going to be different. So that's why that had to be standardized. Does anyone know how many centimeters it takes to make an inch? So now this is the worst thing. How many inches does it take to make a foot? 12. Okay. We all know that because this is the system we grew up in. The worst conversions are between our rear-gas system, based on the length from the king's nose to a thumb. Are you kidding me? Didn't we have a revolution? Why are we still basing it on some old English king's distance? Yes? That's weird. That's just weird. But that's okay. We'll be here. If I'm converting between that system and metric, right? Do you guys know what a metric is based on? The metric system? What is our number system based on? 10. I don't know why. We'll never know why. None of us have a clue why. Yes, we have 10 things. Metric system is based on 10. Do you guys know what it takes to convert between tablespoons and gallons? It's insane. It is truly insane. But if I want to convert in metric, we'll see in a little bit, it's much, much easier because it's based on 10. Let me see. Yeah. Oh. So let me talk about our system of measurement for a little bit, and let's talk about area. So can everybody make a little square? We'll call it a square foot. So this guy's area would be 1 square foot, literally because the area of a square is just length times width, any rectangle. Foot times foot is foot squared. Okay. Can somebody figure out how many square inches there would be in that square, in that picture, in that region? Yeah. So each side is 12 inches. And then if I recalculate the area, 12 times 12 is 144. Inch times inch is square inches. So watch this shortcut. 12 inches equals 1 foot, right? So 1 foot is 12 inches. So what's 1 square foot? Would be 12 square inches. So if I make a cubic foot, 1 cubic foot will be how many cubic inches? Yeah, because I'll have 12 times 12 times 12. I love it. So if you know the length conversion, you just have to square or cube to know the area and the volume conversions. Blah, blah, blah. Yeah. By the way, so this will be 144. This will be, I think, 1728. Let's talk about volume. We sort of already did. One really cool way to figure out the volume of something. Real quick. Have you guys ever, I'm certain you have, when you were a little kid, maybe even more recently than this, been at the beach or in the tub or something, and you would put something underneath the water and let it go and it would fly up? Yes?
Yeah.
Okay, it's still fun. Not necessarily related to that, but if I had a container of water, maybe a graduated cylinder. You guys know what a graduated cylinder is? Where you can read off the side how much volume there is at that certain level? Okay. So if I had water and I put into it some object, the water level will of course rise, yes? That only makes sense because it's being displaced. See, this just makes natural sense to you guys. If I put something in the water and I see how much the water has changed its level, could I figure out the volume of the object I put in to the water? The only reason the water's been displaced, and I am aware of how I said the word water, the only reason it's been displaced is because I put the object in. So let's say before I put the object in, this tells me it's 5 milliliters. And after I put the object in, now it's at 6 milliliters. Well, what's the volume of the object? 1 milliliter. Yeah. So that's using the idea of water displacement to measure the volume of something. Now, real quick, if it's a little cube and I can measure it, do I need anything's help to get the volume of it? Don't we have a formula for that? If it's a little rectangular solid, let's say I've got this here. Let's say it's 1 inch, let's say 11 inches by 10 inches by 2 inches. Could you figure out the volume in cubic inches? Could you figure out the volume? What would the volume be? Tell me what you would do to figure out the volume.
11 times 10.
Yeah. So what's 2 times 11? 22 times 10?
220
Yeah, 220. 220 what?
inches.
Cubic inches. Yes? Because I got length, width, and height. I got to represent that I'm in 3 dimensions now. But if I have something that's shaped irregularly, some little chunk of something, and I want to know what its volume is, I could just do the water displacement method. Does anyone see an issue with the fact that whatever the little thing was I put into the water, I know it's 1 milliliter. But let's say I'm in America, and I need that in cubic inches, yes? That's a major issue. So I need to know how to convert from milliliters over to cubic inches. Okay. All right, we're gonna get there. We're gonna get to conversions here pretty soon. Yeah, Oh, one little thing I want to talk about: temperature. How many temperature scales do you guys know about? Celsius, Fahrenheit, Kelvin. Kick ass. Have you guys ever heard of the concept of absolute zero?
Yeah.
Okay, I think there's been some really dumb movies. What is The Day After Tomorrow? Wasn't that the one with the cold? I never saw the movie. I have no idea. So, In Fahrenheit or Celsius, if it gets to 0 degrees, does that mean there's no heat? No. In Kelvin, if I get to 0 Kelvin, we're all dead. There's no energy. That's what 0 Kelvin means. So it's a little, so we have Fahrenheit, we have Celsius, and we have Kelvin, so thankfully there wasn't some fourth one called like universal or something. We're gonna focus on these two very much, obviously, because not all of us have heard of Kelvin. Those of you who have heard of Kelvin, you must have heard of it in your chemistry classes. Yeah. So let me ask you guys, let me see. In Fahrenheit, do you know the freezing point of pure water? 32 degrees. Yes? So in Fahrenheit, freezing of water is 32 degrees. Does anyone know what it is in Celsius? It makes a lot more sense. 0. In Fahrenheit, does anyone know the boiling point of pure water? And why do I say pure water? Because you put salt into it, you change its boiling temperature. Does anyone know the boiling temperature?
210.
Close. 212. And in Celsius, which is a metric-based system, is based on 10. What do you think the boiling point would be? 100. Now, to really, really push my luck, because you guys all seem very excited about the fact that today's been a lot of definitions and so forth, I'm going to bring in some algebra. I appreciate that. What's that? Let's do that. When you can bug them a teacher, you can do which one. I have 2 points up here. So for example, I have the point 032, if I consider Celsius, Fahrenheit, and the point 100, 212. Yes? I guess we'll put degrees on everybody. All right. I'm not going to require you to remember this yourself, but let me see if anybody does remember this. Do you guys agree those are 2 points? If I want to convert from Celsius to Fahrenheit, I could actually create a formula to do that for me, just knowing these 2 points. And also knowing that it's a linear relationship. So what 2 things do I need for the equation of a line? What 2 things do I need for the equation of a line? In fact, who remembers the equation of a line? Y equals mx plus b. What was m?
M was the slope.
And what's the slope?
X was point.
Good, x was an input, some input.
Y.
B, m and b are the important ones, yes? Because y and x are just going to stay y and x. M is the slope. B was the... Does
Oh,
anyone remember?
the number on the 0.
Okay.
X axis.
So, y equals mx plus b. M is the slope. And b, if I make x 0, y is b. Do you guys see that? So that was the y-intercept. Okay. This is sort of coming back. I noticed some of you guys are actively trying to not let it come back. It's okay. I'm going to tear up later about that, but I'll be all right. The importance of this, especially for us special Americans, is if I want to talk to anybody else in the world, they're all using Celsius. I need to have a formula to convert. So when they say, it was hot today, it was like 17, I'm like, what the hell are you talking about? Until I use the formula to figure out what that was. Not 22 anyhow. So, do I know the y-intercept? Do I know the value of y, of the output, when the input is 0? So in this case, let me see if you guys are cool with this. What's acting like y? Which piece of this would be y?
32.
Yeah, so Fahrenheit's acting like y, yes? So let me make my formula more related to what we've got going on. So I'm gonna make a formula that if somebody tells me the Celsius, I can do this stuff to it and convert it to Fahrenheit, yes? Okay. So how do I get the slope? So this is B. Because that's what Y is when X is 0. That's what F is when C is 0. So everybody with me, roughly. How do we get the slope? Does anyone remember how to do the slope?
Changing X over changing Y, or changing Y over changing X.
I love it. So why does a mountain have a big slope? Because if I try to move a little over this way, don't I have to move up quite a bit? Yes? If I'm talking about doing some bouldering or something, don't I have to go up quite a bit to move over a little bit? Whereas this floor is flat. Roughly flat. If I move this way, am I going up at all? No. So I have 0 height change for some kind of left and right motion. Are you guys with me? So it makes sense, physical sense. If I want slope in math to match up with slope in physical reality, I want it to be how much my height changes over how much I move left and right. So if the floor was suddenly a ramp, now it's a lot more. So have you guys ever gone driving somewhere and first off, and then secondly, you see a sign that says 12% grade ahead? You guys ever seen that? And on the small part of your brain is like, a test? No. So what the hell is 12% grade mean? Well, what's 12% as a fraction? 12 over 100, which is rise over run, which is what slope is. So that means if I'm going up 12% grade, I'm going up 12 feet for every 100 feet forward I go. Does anyone know if 12% grade is really steep or not? 12% grade is steep. In fact, it's like 6 or 7, you start seeing those runaway truck ramps. Has anybody ever seen those?
Yeah.
If you go driving through some mountains, you'll see runaway truck ramps. They're literally just this thing that goes slope up and there's sand so that a truck can run. But if their brakes fail, they can make the sand stop them. Yes? So when I first saw my first one of those, I was like, holy shit, I'm looking out for trucks. Holy shit. If you ever go to like Mission Hills or the road that goes down to the airport, there's a really steep drop off. You guys know what I'm talking about? Yeah, when I was taking somebody with kids, we'd always go that way and I'd say, here we go, whoa! And they loved it. I still do it myself. Now, so in order to calculate slope, I want to see how much did this sucker go up based on how much did it go left and right. Well, how much did the x's change? How much did it run from the 032 to the 100 to 12? How much did it change in this direction? How much did the x parts change? 100, yeah. So it's, I don't know if you guys remember this. y2 minus y1. So this would be, on the bottom would be 100 minus 0. So it went from 0 to 100. And on the top would be 212. This is where it ended up, minus where it started. Yes?
Yes.
The crowd goes wild. This is 180 over 100, which is, bam, bam, 18 over 10, which is 9/5. So if I go back to my thing, I know B is 32. I know M is 9/5. So now I know F is 9/5 C plus 32. Does that look familiar to anybody? You guys ever seen that before? So if it's 20 degrees Celsius right now in Canada, what would we special Americans call it? Can you figure that out? How'd you get there?
So you said 20 degrees Celsius and then cross out 5. And
Good.
then it goes into
Put
20.
a 20 in C. 20 divided by 5 is 4.
And then 9
Times 9 is 36. Plus 32 is 68. I like it. So yeah, now it just becomes, if I tell you Celsius, you can tell me the Fahrenheit just by plugging that in. What if I told you Fahrenheit? What if I said
Work back.
80? It doesn't matter, Jeff. It really 81 degrees Fahrenheit is how many Celsius? What would you do? Where would you put 81? No way. So 81 equals 9 C plus 32. How would you solve it? You would subtract 32. And then the nice way to kill a fraction is to multiply by the reciprocal. Yeah.
So the equation always gonna be the F equals 9/5.
Yes. That is the
Conversion.
conversion between Fahrenheit and Celsius. Yes. Just because of the way that they were defined. Okay. So there, I have no idea. Let's see. You would get 49. You would get. I kind of made that gross tonight. It's too bad.
Yeah.
What is it? 27.2.
Yeah, 27.2.
I like it. Okay. Up. Now, let's focus for a moment on the metric system. So metric system users use Celsius instead of Fahrenheit. The whole idea with metric is they want to use 10 as the basis for it. So for us, we don't have that. How many inches in a foot? How many feet in a yard? How many feet in a yard? 3. Do you guys know how many yards, how many feet in a mile? Does anyone know? You say 102? Imagine going a mile. It's a long ways. If you walk in it, yes. Even if you're driving it, it's going to take like about a minute if you're going 60. Yeah. In fact, it's going to take exactly a minute if you go 60. So it's 5,280 feet. So you were getting there. No, it's fine. It's a lot better than, I saw a video one time of some girls like, if you're going 80 miles an hour, how far will you go in an hour? And she wouldn't accept that it was, you know what I'm talking about? She wouldn't accept that it was 80. She's like, oh, what do you mean? Maybe it's not 80. No. Okay, so metric system, can anybody tell me, this came up earlier, anybody tell me any unit you know in the metric system? Any? Kilometers, okay. That's kilo. Normally we don't know these two. And then I have meters. Then normally we don't know this one. But then we know this one. What's the one that it takes 100 of to make a meter? That's 1,000 for a million.
I got you. I know.
How many, what can you break a dollar up into 100 cents? So the centimeters. For the same reason, we still stole from the Latin speakers, yes. A lot of our unit measurements are based on Romanic, meaning from the Romans. So that's why a lot of them are named after in Latin. So this is centimeter, I'm sorry, this is decimeter actually. Which makes sense because if you think of a meter as a whole number, what's right after a whole number? What starts after that? The decimals. So that's a decimeter. And then you have a centimeter. And of course, deci is based on 10. Centi is based on 100. Milli is based on 1,000. Hey, look at you. Hectometer. And then this one people normally don't know, but it's a deca. So I just always remember between deci and deca. Deca is bigger because damn it's big.
King Henry doesn't.
Ah, look at you. Yes. There's a mnemonic device. Anybody ever play any musical instrument? In fact, yeah, most musical instruments. Okay. Is there a mnemonic device to remember the notes, the scale of notes?
Oh, yeah, wait.
Every good
Boy
boy does
fine.
fine. And then the other one is space, I think, yes?
Face,
Yeah.
and then,
That's all I know, because that's about the extent of my musical knowledge.
I took this
I can play the triangle
a
pretty well.
year ago, so you have.
So there is a mnemonic device for remembering this. Before I tell you the mnemonic device, let me give you motivation why you're gonna wanna remember this. Metric kicks ass, because our number system is based on 10. We don't have any proof of this, but it's because we have 10 freaking fingers. If we had 8 fingers, it would be based on 8. We go 1, 2, 3, 4, 5, 6, 7, 10. Just like last semester when you did base 8. So here's why knowing this kicks a lot of ass. Every step I take is a step of 10. So if I have 1 kilometer, that's 10 hectometers, which is 100 decameters, which is 1,000 meters. And in fact, normally we know kilo is 1,000 from crime shows, because a kilo of cocaine is 1,000 grams of cocaine. You guys with me? See if YouTube strikes me for that. Now, if I want to convert from, let's say I have 12 hectometers, and I want to know how many meters that is. Here's the beautiful way to do this. How many places away from hectometer is meter? 2, yes? 2 from hectometer, 1, 2 to meter, yes? Every step is a step of 10, so I just have to multiply by 10 twice, which means I just have to move the decimal twice in the freaking direction I just went. So if I go from hecto to meter, I'm gonna go 1, 2. I'm gonna move the decimal over 1, 2. So I'm gonna make it 1,200. So if I said I had 14,750 centimeters and I want to know how many hectometers that is, I do the exact same thing. Start at centimeters. How many places do I have to go to get to hectometers? 4, yes. If I start at centimeter, I gotta go 1, 2, 3, 4. So then I move the decimal over. 1, 2, 3, 4, so it's 1.475 hectometers or hectometers. It's up to you. Tomato, tomato. Tomato, tomato. Okay, maybe. Has anyone ever seen this before? You have? Okay. You have? Okay.
Yeah, it's been a long time. I did it in physics and
Yeah, physics. So you know what I'm talking about.
Yeah.
Physics, they get upset if somebody else is using feet and inches and so forth. No, I understand too, because I'm in both worlds. So, if you can write for yourself, kilo, hecto, blah, 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 conversions that I asked you to do are very, very easy. You just have to count and see which way you went, correct? Because it's all based on 10. So if I count 3 places that way, I'm going to move the decimal 3 places that way. So I think, Erica, I think you started saying King Henry died Monday drinking chocolate milk. That's the mnemonic device, like every good boy does fine, which is how you memorize the notes in order. Please excuse my dumbass son, or my dear Aunt Sally, yes, how to memorize order operations. Okay. So let me give you this one thing. We're not gonna have enough time to do it today, but I wanna give this to you. We're gonna get into some more details next time. But this has got on one side some conversions, and on the other side it's got the metric stuff, including all the stuff I just talked about. What do you use in metric to measure volume? When you go to the store, you get Pepsi or Coke. I don't know which one you like better.
Oh, the 2-liter bottles.
So liters for volume. What do you use for mass or on Earth weight?
Ounces?
No, that's not metric. That's us.
Oh.
What did you say earlier about cocaine?
Kilogram.
Yeah, grams. So grams. So the great thing about this, if I just put gram here, then that's decagram, hectogram, kilogram, blah, 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 blah. And if I put liters here, that's decaliter, kiloliter, blah, blah, blah. Metric is so nice. But we're never gonna go there, because Americans would never let that happen. You're not gonna take my inch away. Give them an inch and they'll take 2.5%. Alright, that's enough for today. Next time we'll get into some specifics about conversions. Thank you for being here today.